The quadratic formula is yet another way to solve quadratics. So in this left one here, what we're going to do is multiply everything by 6, since that's the LCD. 6 over 3 is really a 2. 6 over 6 cancels out to 1, and 6 over 2 is a 3. So multiplying by those, we're going to have 2x squared minus 7 equals 9x. And in order to use the quadratic formula, we have to have it set equal to 0. So we need everything on, in this case, the left-hand side of the equal sign. So I'm going to subtract that 9x over. And then we can easily identify our a, b, and c. Alright, using the quadratic formula, we have the opposite of b, so positive 9, plus or minus the square root of b squared. Notice I have to put that in parentheses because we're going to end up getting a positive 81. It's the entire negative 9 squared. Alright, so b squared minus 4 times a times c, all divided by 2 times a. Alright, we have 9 plus or minus 81, and then I have a negative 4 times a 2 times a negative 7, so I have two negatives, going to make a positive. 4 times 2 is 8, times 7 is 56, all over 4. Alright, in our next line down here, I'm going to clean up the discriminant. The discriminant, again, is what's under the square root. So 81 plus 56 is 137, all over 4. And actually, we cannot simplify this at all. So scratch this. This is our final answer because we cannot break down the square root of 137. Alright, in the second problem, we are all ready to identify our a, b, and c because they're all on one side of the equal sign. So our a is a 1, our b is a negative 5, and our c is negative 9. So when we are plugging it in, we have the opposite of b, so positive 5, plus or minus, I'm going to do this part in my head, negative 5 squared will be positive 25, b squared, minus 4 times 1a times c negative 9. And then that is all going to be divided by 2 times a, which is 1. Okay, cleaning up the discriminant, what's under the square root, we're going to have 25, again a plus 36, all over 2. 25 and 36 is going to be 61. We cannot break down the square root of 61, so that's our final solution.